Okay, hopefully you've just watched part B, 18B, and you solved some simultaneous equations. How did you get on? Okay, let's do it. We've got 6a plus b equals minus 3. We got 2a minus b equals 7. If I add these, it's going to get rid of the b's. So let's add them. We get 8a equals 4. Okay, divide both sides by 8. A equals 4 over 8. That should be 1/2. So A is a half. Okay, we've got 6a plus b equals minus 3. We know A is a half. 5 times 6 is 3. 3 plus b equals minus 3. B equals minus 6. Okay, those are our solutions. If you got A equals a half and B equals negative 6, fantastic. You have found the values of A and B. Okay, right, so lots of work to do with the functions before we got to the simultaneous equation stage. Okay, not an easy question. Alright, question 3. Root 2, 3 root 2 and x root 2 are the first three terms of a geometric sequence. Okay, right, this is the crucial word. Okay, you've probably met arithmetic sequences, you've probably met quadratic sequences. You may have forgotten or not really registered what a geometric sequence is. So a geometric sequence has a constant multiplier. So in other words, if we took the constant multiplier as 2 and we started with the sequence 3, okay, I multiply that by 2, I get 6. I multiply that by 2, I get 12. I multiply that by 2, I get 24. This is a doubling sequence. Okay, so if the multiplier was 3, and we started with the 3 times 3 is 9, times 3 is 27, times 3 is 81, etc, etc. So these are geometric sequences. They have a constant multiplier. Right, so what have we got to do? Okay, we've got to take a root 2, 3 root 2. Oh, well, straight away. I'm thinking, well, root 2 times what makes 3 root 2? This is a times 3, surely. Okay, 3 times root 2 is 3 root 2, so we've found our multiplier. Okay, so what comes next? X root 2 comes next. But I know to get from here to here, I've just multiplied by 3. So in other words, 3 root 2 times 3 must equal the next term. Excuse my cats. So 3 root 2 times 3 is 9 root 2. Therefore, x is equal to 9. That's all you got to do. Right, find the value of the 6th term in the sequence. Well, let's list them. Oh, cats. Root 2, 3 root 2. How did we get that? We multiplied by 3. What comes next? 9 root 2. What comes next? Well, it's 9 root 2 multiplied by 3. What's that? 27 root 2. I'm going to have to let them out in a minute. 27 root 2. What comes next? 27 root 2 multiplied by 3. That's 81 root 2. Nearly there. This is 1, 2, 3, 4, 5. What's the 6th term in this sequence? Well, it's going to be 81 root 2 multiplied by 3, which I make 240. Oh, for goodness sake. 243 root 2. Okay? 243 root 2 is the 6th term in the sequence. Right, I'll just let my cats out before they kill each other, and then we'll do the next one. Okay, question 4. A regular octagon has sides that each measure 5 centimetres. Find the area of the regular octagon. Right, if they don't give you a sketch, that would be the first thing that I would do. So it is probably going to need to be a bit bigger. So a regular octagon, what does that mean? Well, it means it's got 8 sides, and it means each of those sides are equal. So it's got 8 equal sides, equal length sides. And it means all the internal angles are the same angle. So that's the same as that, 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 same as that. Okay, and we know that one of those lengths is 5 centimetres. Now, usually in these sorts of regular polygon questions, you're going to have to work out an interior angle at some point. And to do that, we could use the formula n minus 2, the number of sides, subtract 2, multiplied by 180. That will tell us the total sum of the interior angles. So here we've got an octagon, so 8 minus 2, that's 6, multiplied by 180. Okay, so we could do 6 times 180. This is going to be on a calculator paper. Will give us 1080. So 6 times 180 is 1080. That's the sum of all the interior angles. And because it's a regular octagon, and it has to be a regular octagon for this to work, we could then divide that by 8, because there are 8 interior angles. And we get one interior angle is 135. Okay, so 1080 divided by 8 equals 135. So usually in these questions we'll have to work out one of those, and here it's 135 degrees. Okay, could have done that by saying, well, what's an exterior angle? An exterior angle in this polygon is that angle there. So we form a straight line from one of the edges and we work out this exterior angle. What's that exterior angle? Well, exterior angle, easiest way to do that is it's 360 degrees divided by the number of sides. So 360 divided by 8. And we're allowed to, as a calculator paper, we get 45. So an exterior angle is 45 degrees. And we could have then worked out the interior angle by saying, well, 180 minus 45 is also going to give us 135. So those are methods that you need to be able to use. Having said that, I'm not sure you need them in this question. Okay, we need to work out an area. And we could think about splitting that regular octagon into a couple of trapezia and a rectangle in the middle, but we don't know the A and B heights for the trapezia. So I'm thinking maybe triangles. And we've got two area formulas for triangles we could use. We could use half AB sine C, or we could use good old half base times height. So I would have those in mind when I'm thinking about what to do. Right, now there are several ways of solving this. Right, let's think about that triangle there. That triangle there is an eighth of the entire octagon, and because it's a regular octagon, if we wanted to know this angle here, we could do the entire 360 degrees divided by 8, which isn't the same as the angle we were trying to work out on the left, but it's exactly the same calculation. It's 45 degrees. So we know this interior angle, not interior angle, sorry. We know this angle at the centre here is 45 degrees. And we also know that this length is the same as this length. So we've got an isosceles triangle. So we know that these two angles are the same. And we could work out what they are by doing 180 degrees, take away 45 degrees, which gives me 135 degrees. And again, that's linked to the angles we saw on the left, but it's not the same angle. And we could do 135 degrees divided by 2. That's going to give me 67.5 degrees. So both of those angles are very tiny. 67.5, 67.5. Okay, right, now let's blow that triangle up a bit. And let's split it into a right angle triangle. And if we do that, what have we got? Well, we've got a right angle, we've got a right angle, we can worry about one of them. Okay, we knew that length there was 5 centimetres. Therefore that length is 2.5 centimetres. And we knew this angle here was 45. Therefore this angle is 22.5. And do we need that top angle? We may not. Right, so what about the bottom one for a minute? We know where that came from. Let's just put the top one in. Okay, so we've got half of that triangle, that right angle triangle there that we're looking at now in red. Right, well, what could we do here? What we could do with knowing is this length here. Because if I know that length there, I can use this equation. I can use my half base times height. I'd have the vertical height from that 2.5 base. So we're looking at trying to work that out. And if I use trig, we know we're going from this angle here. This would be opposite. We want to work out the adjacent. So it looks like I need tan. Tan of 22.5. 5 degrees has got to be equal to 2.5 divided by our adjacent side. And with a bit of rearranging, that's going to give me that adjacent side is equal to 2.5 over tan 22.5. Okay, so let's do that. We want 2.5 divided by tan 22.5. That gives me 6.0355. Now I'll write it down to those 4 decimal places. So A equals 6.0355 centimeters. So now we know this is 6-ish. 6.0355. So what can we do now? Well, we could now work out the area of this whole triangle because we know its height and we know its base. So we're going to use area. Let's clear some space. We're going to use area equals half base times height, and we're going to use half times the base, which is 5, times the 6-ish, it's actually 6.0355, to give us the area of that entire triangle, which is our unrounded answer multiplied by half multiplied by 5. So the area for that triangle is 15.0888. 15.0888 square centimeters. And how can we work out the area of the entire octagon? Well, it's going to be 8 of those triangles. Okay, so we've got our area there multiplied by 8. Now note, every time, although I've written down an answer, I've left my unrounded calculation in the calculator. So we've done no rounding till the end of this calculation. The area of my entire octagon is 120.71 blah 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 blah. So to one decimal place, our area octagon equals, and this one was area triangle. So the area of our entire octagon is 120.7 square centimeters. Okay, now there were lots of other ways to do that question. So if you came up with a different way, got 120.7, fantastic, well done.